Let's go to Lico 3249. Count the number of good nodes. For this question, it gives us tree, and let's count the number of good nodes. So the definition of good node is that all of the subtrees rooted at its children have the same size. So for this question is that it gives us a two-dimensional integer array ages. Of course, we need to convert this as a map or list of integer array, right, as a tree. And what we're thinking about is that we do the post-order traversal to count DFS average its children's for a node, right? For DFS, its children's good nodes, right? So in the for every its children's good nodes, the total counts will add to current nodes. And during the DFS, we should have another result is we want to compare the every children their size, right? If their size are equal for our current nodes, the good node means our current nodes, it is a good node itself. It is a good node, so it will add equal to 1, right? So our DFS should return two results for current nodes. The size for current nodes, how many good nodes. So in this case, let's write code for this, right? So we need to convert this one as the map, right? So we have list of integer map equals new hash map. So what we do is that for age in ages, we're going to have map compute effect since age there k goes to new array list at age 1. And also we need to do this, right? So then what we need is that we need to DFS, right? So we should return two results. Actually integer array, right? So result equals DFS something, right? DFS we should have the tree, and we are from the root, right? And so result 1, right? We will say result 1 will be the size of this tree, right? And result 0 will be the size of the tree, and result 1 will be the count of good nodes, right? Counts of good nodes. So we know for this map, right? So it just list for every node what's its neighbor. We know that when we do traverse to its children, we should ignore the parents. So we should also have a parent parameter passing into the DFS, right? So for the root, let's say the parent is -1, right? Let's set this one. And then in the end, we just return result 1. So private DFS should have map integer list of integer tree, so into current int parent. So what we do is that we're going to have int result equals new int 2, right? Actually, when we DFS here, right? So we'll see our current will not be none, right? And then the tree size is n is greater or equal to 2. So and also what we do is that when we iterate its child, right? So when the child will always have value, right? So that means when we DFS it to this layer, this current will not be none, right? So we can set this size to be 1, right? And the good node is set as 0 initially. So what we do is that if this map contains key current, this tree, right? If this tree contains key current, then what we do is that for into next tree get current. So what we do is that if this next equals current, so we should continue. And then we're going to have answers equals DFS tree next current, right? So this is for its children. Then we'll see result 0 should add equal to answers 0. And the result 1 should add equal to answers 1, right? So the good nodes, we should add all of the children's good nodes. And whether this node itself is a good node, we should compare, right? So how can we compare? First, we can have size outside. Input size equals -1. First, we have Boolean is good equals true. So let's say if size equals 1, right? Then we're going to have size equals answers 0. And else if answers 0 doesn't equal to size, then we're going to have is good equals false. And well, in the end, let's say if is good, that means this node itself is a good node, then we'll have result 1 should increase by 1 because this is itself is a good node. And in the end, we just return result. The time complexity will be O(n) because we do a post-order traversal, right? So we traverse every node. In the space, we use a map, which is also O(n) space complexity. Write code, Python code for this as well, right? So let's compose a tree, right? Tree equals initially set an empty tree, right? For age in ages. So let's say if age is 0, not in tree, right? Then what we do is that we are going to have tree age 0, set a new list to it, right? And also if age 1, not in tree, we'll have tree age 1 was a new list. Then we have tree age 0 should append age 1, right? So this list, right? So we get this list of age 1 as well. And for this list, we should append age 0. Okay. we should have results equals DFS tree 0 parents, right? And in the end, return result 1. Let's define the DFS, right? DFS should have P, that is the int list of int, right? And we should have parent as int, parent as int. It returns list of int, right? So we know result 0 is size, right? And result 1 is the good nodes count. So let's initially set 0, 1, 0, right? So size is good equals -1 and is good equals true. And for so what we do is that if current in tree, right? Then we're going to do for next node in tree current. So if next node equals current, we're going to continue. And we're going to have answers equals DFS tree next current. So we're going to have result 0 should plus equal to answers 0, and result 1 should plus equal to answers 1, right? What we do is if size equals -1, right? What we do is that we should size equals answers 0, right? And else if answers 0 doesn't equal to size, then we're going to have is good equals false. So what we do in the end is that whether we should add it, right? If is good, then we'll have result 1 should increase by 1. And in the end, we return result. Two. Append 0, 0, return this one. This is true for every current if next tree, if next equals parents, continue. So this is not next, should be next node, right? Next node.